This is Ben from Testive, and we're solving an SAT geometry problem. This problem asks, in the figure, if line L, that's this line that we can see right here, has a slope of 3, what is the x-intercept of L? So we're looking for the x-intercept, which is this right here, where y equals 0. So we actually already know that we're looking for x, 0, because that's what an x-intercept is. We also know another point, this right here, because we can notice that this point will be -2, 6, because we can just match it up with this and this point. Okay, so if this is -2, 6, and this is x, 0, well, first thing that we can do is we can actually rule out a couple answers. It's not going to be 3 or 6, because we can see that the x-intercept is negative. But now we can use the point-slope format. Remember, the point-slope format is y1 minus y0 equals m times x1 minus x0, where x1, y1 and x0, y0 are 2 points along your line. Well, we have 1 point along our line, -2, 6. So we can substitute that in, along with the part that we know from our other point, x0, which is the 0, and then solve for x. So we can put in, we want to make sure that we don't accidentally put in 6 minus 2 or something like that. Remember, this is an x and a y right here. So we want to put in our 6, let's say right here for y1. Okay, I'm just going to fill it in like this. Our slope is 3, we know that. Our x1 is -2 because we match these up, y1 and x1. Minus, we don't know our other x, and this will be -0. So 6 equals, now we just distribute, -6 minus x, okay? Oh, sorry, did I say that? 6 equals, so that's where it's easy to make a mistake. I'm going to leave this in. I'm not going to edit the video because that would be an easy kind of mistake to make. So I just messed up my distribution. So we're actually distributing the 3 here. So 6 equals 3 times -2, which is -6 minus 3x. Okay, so that means we're going to add 6 to both sides. So we get 12 equals -3x. And that means that x equals -4. Okay, so that's our answer right there. Now, luckily, if I messed up my distribution like that, if I forgot to distribute the 3, I would have ended up with an answer that didn't make sense. So I might have been able to go back and catch my mistake because I would have gotten x equals -12, which isn't one of my options. But you want to be careful for simple mistakes like that. Don't get overconfident like I did. Make sure that you check your work on straightforward procedures, often more than even on complicated ones, because that's where it's easy to make mistakes.